To start with, we will go ahead and talk about networks. The reason why I would like to talk about networks is primarily because you and I know that nothing can exist without a network. A cable is a must, an IP address is a must, even though it's in the cloud, on wire, or data transferring wirelessly. We need networks. And hence it is paramount that we speak about networks in any such discussions first. And then we'll start deploying virtual machines. Now these virtual machines in cloud, specifically Amazon Web Services, are called as EC2 instances. EC2 instances. So we'll start using AWS specific terminologies here. AWS uses VPC for networks and EC2 for instances. Now, I do not have a lot of presentations here. This is a technical class, and I will stick to doing hands-on labs rather than showing PPTs after PPTs and then just talking. So, and also I have a lot of projects that I do. I'm not a trainer, and hence I do not have any presentations. All I do is in my regular meetings with my customers, I go ahead and talk to them over a board meeting where I draw the diagrams and not using presentations or visuals. And that's something that I'll be doing here as well. I'll be using very basic tools like Notepad, sometimes Microsoft Word, MS Paint, or any other tools to draw diagrams to represent the thoughts in my mind in a simplistic way rather than using complex animations or PowerPoint presentations. So we'll talk about VPCs, EC2 instances, and S3, and we'll also be talking about, S3, we'll have a deep dive on storage and hybrid storage specifically. So how do you integrate your on-premise infrastructure storage with the cloud storage, which we call as S3 today? S3 stands for Simple Storage Services. Now, because they have 3 S's, they just call it as S3. So we will also talk about disaster recovery, and business continuity. The first couple of blocks, VPC, EC2 instances, and S3, are basics, which some of us may have already gone through in the previous sessions or maybe in your regular lives in your office. The remaining 2 sessions are specifically part of this agenda. The reason why we have the about 3 bullet points, networks, EC2, and storage, because most of us said that we want to go through basic concepts as well. So every day we will be going through basics, and then anything that's advanced inside that will be covered as later part of the section. So going back to this, here we'll be talking about connecting an on-premise data center to the AWS cloud, and this is specific to networks as well as storage. And then business continuity and disaster recovery, which is part of AWS WellArchitected Framework. There are 5 pillars of a well-architected framework. And one of the pillar is called as resiliency or availability, which is closely related to disaster recovery and business continuity. So one of the pillar is something that we can talk about today. Another pillar is cost optimization, which comes in the billing implications. There are other pillars as well. For example, security is a third pillar, which we'll talk about in this section, which is protect your infrastructure from DDoS attack. and designing protection of data at rest and data in transit. Encryption is also part of the security. So these three options that you're looking for, bullet points that you're looking for, are coming under the section of security pillar. Performance is the fourth pillar, which comes under enhance the performance of your solutions. So as we go through these bullet points, we are basically covering the well-architected framework and the 5 pillars that are defined in the well-architected framework. You may be thinking, who actually defined these 5 pillars? Is there a standard? Well, the standards called as NIST, which is National Institute of Standards and Technology, or the FISMA standards, or ISO, IEC standards. There's so many standards and regulations around the world today. Well, they did not define these pillars. What they defined is the definition of cloud computing. And I may be repeating this and you may be already knowing this, but the definition of cloud computing is given by one of the organizations that you already know, which stands for NIST, the National Institute of Standards and Technology. And another company, or rather say organization, just called as ISO, IEC, which came up with its own definition. But both of them mean the same thing. And it means that if you're able to create resources, or rather keep it more technical, if you are able to provision and deprovision resources from wherever you want at any point in time, from whatever device, as long as you have internet, as long as you have your device web enabled, and then you really do not need to have any intervention from the cloud provider to create that resource. And that resource could be a virtual machine, an EC2 instance, network, storage, databases, anything. I do not want to call up Amazon, land up in the customer care queue, and when they call up or pick up my phone and say, hey, thank you for calling Amazon, can you tell me what you want? I'll say, hey, can you help me create a virtual machine with like 30 GB of disk, make sure that is general purpose provision IOPS of at least 4,000 IOPS, and I need 4 gigs of memory, make sure that you got port number 22 and port number 80 open. Well, that's not what we want to do, because we today have a self-service provisioning portal where you can type your user ID and password to login. And once you log in, you enter into the world of cloud services provided by AWS. So because we're talking about Amazon Web Services here, we'll just try to sell AWS. So you enter the world of AWS services, so you can create what? Anything. EC2 instance, relational databases, storage. There are different kinds of storage. You can create NFS, EFS, elastic block storage, well, object storage, or maybe a block storage. You can also have DNS in the form of Route 53. You can have monitoring done in the form of Cloud Watch. Well, this list that we can write, this is just a small list. And yes, some of us are from Citrix and VDI background. I know Abhishek said he is from the Citrix background. How about VDI? Yeah, you can definitely create workspaces for VDI. Yeah, people are from Linux background. You can create instances of EC2 of any kind or any instance type. There were people from storage background, so they may be more interested in block storage, specifically EBS, NFS, which is EFS, and object storage, which is S3, anything. Mountable storage and unmountable storage, right? Now, this is the definition given by NIST, and ISO or ISO IEC also came up with a similar definition. But the bottom line is just the same, right? You create the services wherever, whenever, at any point in time without calling your cloud provider, with minimal intervention from cloud provider using the self-service provisioning portal is cloud computing. Now, every cloud provider started to give advices and say that, hey, this is the right method of provisioning infrastructure, this kind of infrastructure in the cloud. Amazon Web Services came up with its own set of suggestions, and they called it as well-architected framework, which are the 5 pillars of well-architected framework, which you just said. For example, resiliency, cost optimization, performance, security, etc. Right? Okay. So there's this quick question that came up in the chat. Could you please record? Yes, this session is being recorded. And then could you please write what are the 5 pillars? Well, let me tell you that I am a lazy admin. I'm a lazy admin. I always just Google and say what are the pillars? So click on that, and then yeah, framework, operational excellence, security, reliability, performance, efficiency, and cost optimization. Looks like there are 6 now. They initially started with 5, and this is something new. 1, 2, 3, 4, 5. Yeah, these were the 5 that already existed. The people who prepared for the Solutions Architect Associate certification or are already certified might have gone through these white papers. So it is paramount that if you're preparing for the certification, could be professional or associate, you must be aware of these 5 pillars. And I've put the link in the chat, and I suggest to go ahead and click on these PDFs and give it a quick read. Just to share, we were like a lot of like-minded people in our office, and all of us were technical enthusiasts and passionate about new technologies. So 10 of us got together in a room and said that, hey, this is just too much to read. When I click on PDF, it may be around 80 pages, operational excellence another 80 pages, and all of us were like me, we're like lazy admins, we don't want to read. So we said, okay, let's get together and you read framework and I will read operational excellence, another person will read security, and the next day we come back together in the conference room and then start discussing about the bullet points, the key points inside each of these white papers. That way we save a lot of time to prepare for the exam. Going back. All right. Amod, does that answer your question?
Yes, thank you.
Thank you. All right, let's keep moving here. So I did mention at one point that we'll start from networks, and we'll start with the very basics of networks. And I think at this point, after listening to your introductions, I do not feel a need to tell class A, class B, and class C, etc. Right? Well, they come under RFC 1918. So according to RFC 1918, there are classes of IP addresses, class A, B, C, D, and E, and then everything has its own set of ranges, and I'm sure you know about it. So let's go ahead and discuss further on it and understand what's going on in the networks. The smallest network that you and I have worked on is the one that you have at your home. Minimum a laptop, probably a mobile phone, a device, and then your wireless router. Everybody has a laptop, maybe, if not a laptop, maybe a tablet or something. So you've got 2 devices and they are like chatting between each other. There's a lot of noise that's heard in the software called as Wireshark. So if you are not aware of this tool, please go ahead and install it, learn it. It's an amazing tool that will let you post-mortem the data that is in transit flowing from point A to point B to let you look at every little bits and bytes of data. Another thing or another tool is called as Ethereal. Microsoft has another tool called as Netmon. So give these tools a shot, play around that, and once you start using these tools, you will fall in love with networks. Moving ahead, I've got 2 devices, that's A and B, and I'm calling my device A as my laptop and device B probably another laptop or my phone or any other device in the network, right? And then since these are devices, they will have certain TCP/IP properties. For example, if I look at my device and I do IP config, it gives me certain TCP/IP properties like this. I got an IPv4, a subnet mask, a default gateway, right? So, and there are lots of others as well. If I do /all, you get a lot more properties. So we will be going through certain TCP/IP properties here. Well, you might be saying, hey, this is an AWS advanced class. Why are you talking about the TCP/IP properties? Well, it's because when you create a VPC in the cloud, you punch in something called as CIDR block, right? You punch in something called a CIDR block. And they usually look like this: 192.168.30.0/24 or 192.168.0.0/16 or something like that. Yeah. The objective in this discussion in the next 30 minutes is to understand, what is this /16? What is this /24? What if I put /8? What's going to happen? What if I put 28? What's going to happen? Right? Can I put 40 here or 50? Can I just put 40 here as well? Right? What is a subnet? What is subnetworking? What is subnetting? Are they same? Are they different? What is the need for subnetting? What is the need for isolating networks? So these are the things that we will understand in this discussion, right? Now, I've got device A, and as per IP config, I got an IP address of 192.168.30. Let's say 50. I'm just putting some hypothetical number there. And the device B is 192.168.30. Let's say 40. What is 0? 30.40. And then since these two devices, my laptop and my phone, both of them are sitting in the same network, within the same room, probably in a different room, but they are in the same house, connected to the same network. So, and hence they will have same subnet mask called 255.255.255.0. And this guy will also have the same subnet mask. And I'm just giving some hypothetical famous subnet mask. Most of the devices at our home have 255.255.255.0. That's defined in your wireless router, yeah. And I'm gonna put a device called as wireless router in between device A and device B, right? That's there. Okay. Yeah. Awesome. All right. Now these numbers are so good for us, like 192.168.255, 40. We understand them. It's for humans, not for computers. Computers understand just two things: 1 and 0, and 0 and 1, and 0 and 1, and 1, 1, 0. They just love these two bits and bytes, on bit and an off bit. That's all. They don't know anything else. The numbers that we just punched in here are good for us, not for computers. And they are decimal numbers. We understand decimals. Computers understand binaries. So let's understand networks the way computers understand by converting decimal to binary. Okay. Now, probably in our school or college, we had the subject of digital electronics, where we used to convert decimal to binary and binary back to decimal. That's what we're gonna do now. And I will be very lazy as always. I'll use a calculator to do that. Now, programmer mode is already on. This is no special calculator. When I do start run CALC, I get that box. Change the standard mode to a programmer one, and then type 192. You get the output right there. Control C. I got 192.2 there. Okay. And we'll do the same thing for 168. Decimal 168. No, 168. And I got this. How about 30? 30 is a couple of zeros, 4 ones, and a 0, right? So there goes 1, 1, 1, 0. Done. What's 50? Decimal 50 is 0, 0, 1, 1. That's how it looks like. Okay. Now, 255 is all ones. 255 is all ones, something like that. So I'm going to do it quickly. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 and then 0 is all zeros. 1 2 3 4 5 6 7 8. All right, so we got the decimal values converted to binaries. Now again, in electronics there is something called as AND operation, which is also called as AND gates. People from electronics and digital electronics background, electrical background, computer science background will know AND operation and AND gates, but again, if you don't know, that's fine. It's not a rocket science. It is just multiplication of 1 and 0, right? Just multiplication of 1 and 0. Now, let's go to, there's our friend Google. Say AND gates, right? Let's go to Google and type AND gates, and yeah, that's how a AND gates look like. It's multiplication. Input A, 0 and 1 is 0. 1 and 1 is 1. 1 and 0 is 0. 0 and 0 is 0 because it's just multiplying. On the other side, this is an OR gate. This is an OR gate. This guy is an AND gate. Okay, AND is multiplication. So I'll go ahead and multiply the IP address with what? With subnet mask. And what do I get? Well, that's how it's going to look like. 11000000 dot 101010 000 dot 0001110 dot, and this guy's going to be all zeros because I've got 0 multiplied by anything is 0. Okay, that's a rule. 1 2 3 4 1 2 3 4. Okay, yeah. Awesome. You just learned multiplication. All right, so that's for device A. Let's also do the same thing for device B. Okay, so we got good 80% job done here because we know 192, 168, 30 will remain the same, and we just got to figure out what is 40. What is 40? I got a feedback here that my voice is breaking. Is it for everybody? And if that is for everybody, it's not good. I will do something about it.
No, I can hear you properly.
Okay. Okay, thank you. If at any point in time you see any quality issues, please feel free to interrupt and stop me right there. Okay, thank you. All right, so there we go. We're back to the same discussion. 192, 168, 30.50 is done. We're doing the calculations for device B. And then we got good 80% job done because we calculated for 192, 168.30, and 40 is, and we don't care what it is, let's just put y there because y multiplied by 0 is 0. And that also tells me that regardless of what I put here, 40, 50, 60, 100, anything, cannot be 60, 100, but 100, it really doesn't matter because the output is always the same, right? Now, what is the crux of this discussion? What is the bottom line? Device A and device B, they are in the same network, and hence they have the same subnet mask. And when device A wants to send the packet out to device B, they will do this calculation. And if they get the same output, they know that they are brothers in the same house. They are brothers who live in the same house. That means they are devices that are in the same network. All right? And if they're in the same network, they don't need to go out of the door because they are living in the same house. If people are living in the same house, they don't have to go out of the door and then talk to the people inside it. They can just shout from one room and another person will hear it, right? So these devices that are in the same network do not need the gateway / router, right? The gateway is like the door of your house. Any data that needs to go out of your network and then it needs to go out and talk to a device in a different network, that needs a gateway. And how does the device A know whether this packet needs to go out or stay inside the network? By doing this calculation. After doing the calculation, if the outputs are same, they will ignore the router and then talk with each other directly because they know that they are in the same house. But the moment the outputs are different, they now know that, hey, this guy is not in my house, and only guy who can help me, who can rescue me, is the wireless router who can route the traffic to the device B. He knows the routes, he knows the path to device B. Okay, is this discussion clear?
Yeah.
Thank you. Moving forward. Now, I remember I was filling up timesheets back in the olden days, a few years ago. The organization got in a system to micromanage our team. So they said, hey, fill up the timesheets every day. I said, okay, 9 to 5, what I was doing, Mondays, what I was doing, Tuesdays, hour by hour has to be filled up in the timesheet. So I said, okay, let's follow the process. I'm being paid to do that, right? Now, let's just open another notepad here, okay? And get into the same discussion, A and B. Now A is your laptop and device B is timesheet, okay? Device B is timesheet. So your laptop and the device B is timesheet, all right. Every day you get into your office, do your work. When you're done with your work at about 4 p.m. or 5 p.m., you do http://timesheet and fill it up, all right? Now this timesheet is also connected to the database. That means when you do HTTP transactions, you are sending the data on port number 80. The timesheet server then talks to the database on the database port, which is 1433. Let's say it is 1433. Microsoft SQL port is 1433. If it's Oracle, MySQL, they are different. Postgres 5432 port number, they're different. Let's just say that it is Microsoft SQL port. So listening on 1433, right? Now A and B are in LAN, and we know that in LAN, all ports, all the way from 0 to 65535 are open. That's the range of ports, right? So not just port number 80, but 81, 82, 85, whatever, 1433 is all open. And this guy who is filling up the timesheet is kind of unethical, right? An internal, I'll say attacker, right? Or probably a lazy admin like me. He doesn't want to fill up the timesheet, and what he does, he does the CRUD operations. People from the database background and who are not from the database background as well, you know that CRUD stands for creating the tables or creating the data in the tables, reading the content, reading the data, updating the tables, and deleting the content from the tables is CRUD operations. Now, because port number 1433 is open to the database, this guy can query the SQL database, which is not good, right? The irregular transactions must be from the laptop. He goes and communicates with the timesheet server. Timesheet server then talks to the database and port number 1433, and the CRUD operations happens from B, not A. But because this guy is a sneaky guy, he does all the queries himself and starts modifying the timesheet, which is not good. A lot of issues, compliance issues, audit issues, payroll issues, and it can just lead to anything. So one fine day, audit happens. The auditing team detects this. By looking at the logs, they say that, hey, all the changes that are happening on my database must be happening through B only. So the source must be device B and the destination must be database. But if you look at the audit logs, the changes are happening from IP addresses that belongs to someone else, but not to B, right? They decide to put this timesheet off the LAN and they put a firewall right there, right? So auditing team contacts the network team, right? And suggests to put a firewall right there. Well, they know who the person is. They know who A is, but they're taking it easy on him at this time. So they contact the network team. Then the network team then goes through the change management procedures to procure the firewall, gets the firewall, and puts it right there. And you know that every time you get a firewall just says explicit deny. Well, I really don't care what kind of traffic is getting in, but I will explicitly deny anything that gets inside me, because that's what firewall does by default. It's an explicit deny. So you then have to write your own rules to allow and deny the traffic. So you start writing the rules in this fashion. How do you write rules on the firewall? You put the source IP address, then the destination IP address, then the port number, then protocol, and status, whether you want to allow or deny. And then you may want to put some status or remarks that will say, hey, the following person asked me to add a rule, and I added the rule by following the change management, and here's the change management number. And usually people use ServiceNow because that is now becoming famous tool for all your ITSM works. In this case, my source IP address will be 192.168.30.50, which is my IP address of device A, and the destination is 192.168.30. What's the timesheet? 100. Okay, 100. And the port number that I want to allow is 80, probably 443, because now I want to do HTTPS transactions. 443, and then allow it, and I'll say, hey, the following auditing happened, and here's the change MGMT number. Great. We are in IT. We have solutions. We have solutions because there are problems. When there are problems, we identify them and create solutions for them. And this is one of the problems that we solved. This guy is a snaky guy, and we solved the problem by introducing the firewall and writing a rule. Any questions so far? You're almost done with this discussion. Almost there. Are you good so far? Okay.
Yes, Anand.
Wow. Thank you. Thank you. All right. So now with this, a new problem starts. We solved one problem. We got rid of all the sneaky activities. But then after introducing this thing, we have another problem. Now we have static rules. You know what? These rules are also called as ACLs, or also called as rule-based access controls. Right? Rule-based access controls. So you've written a rule or an ACL there. But this IP address that belongs to this guy will be changed after a few days because DHCP will kick in. DHCP stands for Dynamic Host Configuration Protocol, and that's responsible for leasing. It's not giving the IP address permanently unless you do a reservation on the DHCP. So it's leasing IP addresses temporarily. If you look at this, my command prompt, I did an IP config and it's ready to see. I got an IP address from IP address from whom? DHCP. My DHCP is enabled. Yeah, I got an IP address from 192.168.1.1. My router gave me the IP address, and it's valid only for few hours. Depending on the organization, they may want to set up the DHCP lease from few hours to few days. It all depends on the organization and admin how they want to set it up. Okay, so with this guy who was a sneaky guy, he got a new IP address. Now he got 30.60. Well, no, not here. He got 60, 192.168.30.60 after the third day. And again, he will not be allowed to fill up the timesheet because the traffic that hits the firewall will be denying it, because the only IP address that's allowed is 30.50 and not 30.60. So he will create a menace. He will contact the help desk and say, hey, you added a firewall and now I'm not able to fill up the timesheet. I was able to do it on day one, but today it doesn't work, whatever. So the network admin will again identify his IP and then put his IP address there, and then remaining set of things that it needs to put here. But then it's gonna be continuous. You don't want to keep doing this because he's not the only employee filling up the timesheet. There are 200 other employees. So you don't want to write 200 set of rules. Instead, what you will do is put a network range. And that network range is what we call as a CIDR block. And then for this specific network, which has an IP address of 30.50 and a subnet mask of 255.255.255.0, the CIDR block will be something like this: 192.168.30.0/24. Now you'll ask me, where did this /24, where did this number come from? Well, this part came from the subnet mask. If you look at it, this subnet mask, convert from decimal to binary, you will have 24 ones, 8 and 8 and 8. And I'm using this set of ones in the placeholder after the slash. So 24, or the number after the slash, represents what? The number of ones in subnet mask. So if you write this part, the CIDR block, on a piece of paper and give it to the network admin, he will understand quite a lot of things. For example, what is the subnet mask? What is the network ID? What is the host octet? The number of hosts that can live in this CIDR block. In this case, my subnet mask is 255.255.255.0 because I've got 24, and now I'm translating that 24 to the ones and then translating that to digital numbers or decimal numbers, which is 255.255.255.0. My network ID will be the first 3 octets because the first 3 octets are masked by my subnet mask, which will then be 192.168.30. The host octet is the last octet. It is a lost. This part will be the host ID, and the total number of hosts in this network will be contained in the last octet, which starts all the way from 192.168.30.0, 30.1, 30.2, 30.3, all the way up to 30.255. But the first ID, which is 192.168.30.0, and the last IP address 192.168.30.255 are not used for assigning IP addresses because the first IP is used by the networks and the last IP address is used by or used for broadcasting purposes. So the total number of IPs we got here is 0 all the way up to 255 is equals what? 256. 0 to 255 is 256, and then we're getting rid of 2, so 256 minus 2, doing the basic math, I'm getting 254. That is in regular traditional networks. In regular traditional networks with a CIDR block of 192.168.30.0/24, you get 254 devices. But in cloud, just any cloud, you got to do -3, which is 256 minus 2 and -3, which is 251. Keep in mind that this is for just any cloud, Azure, AWS, or Google Cloud Platform. It is, or any cloud, which even if I don't list it here, they will have -3 because these 3 IP addresses are then assigned to the managed devices. Well, if you think about it, you are losing these 3 IP addresses anyways on your premise as well. 1 for the router, which is the gateway, 2 for the DHCP server, 3 for the DNS server, and these 3 are managed services. Managed. These are managed services in cloud. So we see, and hence we lose them here as well. On-premise infrastructure, you used to manage them, and in cloud, it is managed by the cloud provider. Any questions, please? In the next section, we'll start building some networks. We'll draw diagrams and represent those diagrams in the cloud, which will happen for another next 30 minutes. Any questions, please? Okay, so since there, okay, what 3 IP addresses are reserved for the devices? We will not know. Unlike on-premise IP addresses, unlike on-premise stuff, we have the option to select the IP address that you want to give to your device. But in cloud, you do not have that option. Okay, guys, it's been close to an hour and 15 minutes. Let's go ahead and take a quick break. Let's see how I can set up a timer. Okay, gentlemen, we'll resume the session after 10 minutes. We spoke about the very basics of networks, the CIDR block, which is also called as a network range. Also understood how the rules or rule-based access controls, ACLs, are written on the firewall. We will take this knowledge forward and understand how you can build networks. Understanding subnets or subnetworking is what we'll learn about. Hopefully my audio is clear and you can see the movement on my screen. Okay, I'm launching MS Paint, and I usually use this tool apart from Microsoft Visual, which is another interesting tool that we use to build infrastructure in the cloud. But at this time, let's just stick to basics. We don't want to complicate the tools that are used here. Okay, so based on this discussion, we said that we will have 254 devices if we have /24 network. What if we have a larger network, or rather just say 192.168.0.0/16? Can you tell me how many, or what is the subnet mask? Just based on the logic that I told earlier. What is subnet mask? What is the network ID? And how many devices will we have in this network? You can post your answers in the chat. Okay, we're getting answers already, which is great. All right. Okay, so I've got one answer which says subnet mask is 255.255.0.0. You can unmute and tell the answer or put that in the chat. Yeah, that's right. That's correct. Awesome. So we got two answers correct there. Subnet mask is 255.255.0.0 because we got 16 ones. And 16 ones, when translated to decimals, will have 8 ones and 8 ones, and that's 255.255. The network ID is the first two octets, which is 192.168. And what's remaining is the last two octets, which will be for hosts and devices. So the last two octets are for hosts, and if you calculate them, they will be close to 65,000 devices, which is 256 multiplied by 256. It is not plus, it is not addition, it is a permutation combination, and not simple addition. So permutations of the numbers inside these two blocks or octets will be about 65,000. So in a CIDR block, which is 192.168.0.0.16, you will have 256 devices. Sorry, you will have 65,000 devices. I'll go back. I was telling that we will be creating a network here, which is something like that. And I'm going to give it a CIDR block of 192.168.0.0/16. All right, and then we'll also have subnets inside it, because you know that inside this box you will have a lot of devices, about 65,000 devices, and it's important that you create isolated networks for various reasons. And I'm going to create a couple of isolated networks. Let's just start with two isolated networks here, and I will have a CIDR block of 192.168.30.0/24 and another CIDR block of 192.168 or probably 40.0/24, and I've got two subnets, and this is subnet A and this guy is subnet B, right? I've got two isolated networks. That means when I create virtual machines inside this, like this, virtual machine 1, virtual machine 2, and 3, and probably let's also bring up a database right here. That's my database, right? There is no way that these devices can talk to each other by default. So devices in subnet A cannot talk to subnet B, devices in subnet B by default because of isolation. I'm saying by default, but there are provisions that one can make or write rules that can be written to allow communication from devices in subnet A to B. But by default, they don't talk to each other. It's only for isolation, segregation purposes. So the first step that we did in order to create a VPC was simple: create a VPC. The second step was to create subnets. Remember that this is a closed network and you need to have some kind of provision, or let's put it technically, we need some kind of a gateway. That's my gateway. We need some kind of a gateway to let the traffic go in and out. And I'm going to call it as a default gateway or network gateway. So I'm going to create a internet gateway of some sort. And then finally, I do have to write the routes to allow, or what is it, allow traffic from a source. So you have to write, or basically edit a route to write a rule. Okay, you have to edit a write to write a rule inside the route that is created by default an internet gateway. Any questions? Okay, so I'm currently in North California region. There are like quite a lot of regions here. Let's just quickly count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, About 16 of them, I think. Yeah, about 16. Whatever. So we've got quite a lot of regions. There are new ones as well being populated here. I remember there were like 13 of them, and then 14. EU Frankfurt was introduced later. Canada Central did not exist earlier, but it was introduced 2 years ago. Basically, Amazon is expanding its wings all across the world with its new data centers. But every data center, every region has a set of data centers, what they call it as availability zones. And availability zones are geographically spread within that region. For example, if I click on North California, it may have like 2 availability zones. North Virginia will have 6 availability zones, right? In India, there's a region called as Mumbai. In Mumbai, there's 2 availability zones. In Frankfurt, there are 3 availability zones. So availability zones are data centers within the region which are spread across that region with minimum 100 miles distance. So just in case something happens to that data center in that region, you still have data in different data centers in that region. So North Virginia is most like a guinea pig for Amazon. So any new service or any new experiment that they want to do is done in North Virginia. And that's why they got 6 availability zones in North Virginia. That's pretty big. I will go ahead and click on your VPCs, and you might have already observed by now that every region has one VPC by default, and that will be mostly in the class B range. And I will go ahead and create another one by clicking on create VPC. So make sure that the names that you give follow your naming standards of the company. I really don't like using this thing called test or test_VPC. I'm not saying that it will not work. It will absolutely work. It has nothing to do with the names, but it's always important that we follow the naming standards. And the standards are defined by your company. You need to ask your standards provider within your company to find out what the build guidelines, what are the naming standards of the resources that must be created in Amazon. The name, I will just give it as VPC underscore, probably the data center region itself will say west underscore 1 or something. And the CIDR block, as per our diagram, is 192.168.0.0/16. I'm getting a feedback here, and my audio is low.
No, look, first it's okay.
Okay.
Yet it's okay.
Okay. Maruf, can you please maybe increase the volume? Probably that will help.
Let me check.
Thank you. So being an architect or a designer, it's paramount that you put your ideas on paper first, which we just did. This is our paper, and we have our ideas that this is how my VPC will look like. It's very important that you draw the diagrams. Use just any tool. It could be simple pen and paper. Draw the diagrams, picturize how the network will be, and then we'll go ahead and start building infrastructure in AWS. And that's how it used to happen in the traditional infrastructure as well. I'll put my CIDR block here, which is 192.168.0.0/16. I don't want an IPv6, and I'll leave the tenancy as default. Create. So that was the first step that we wrote, which is creating the VPC. It says done. Next, creating subnets. I'll create 2 subnets because that's what I said that we'll do in the picture there. All right. Notice that I have a VPC identifier as well. I have a VPC identifier with this name, VPC hyphen a random alphanumeric ID. Now I want to create subnets inside it. So I'll go to subnets and then create subnet. You can use subnets like that, use subnet A, subnet B, or use business specific strings there. For example, healthcare. And my VPC in which I want to populate this is this one, VPC underscore west underscore 1 availability zone. I see that there are 2 availability zones in North California. You may be creating your VPC in Virginia, and if you do that, you will see 6 of them. Mumbai, you'll see 2. In Europe, Frankfurt, you'll see 3. So depending on the region where you are in, you may see an availability zone. Like I said, availability zone are nothing but massive, large data centers, which are separated by at least 100 miles. So distance between A and C is considerable. It's pretty big. So if just in case if there's a natural catastrophe or a man-made disaster, they'll have just some part of it losing and not the whole thing. 1A, and the CIDR block, as per my picture, for the first subnet is 192.168.30.0/24, isn't it? So that's done. And now in continuation to this, we'll create a second subnet as well, and I'm going to call my second subnet as banking. Put that in my VPC, and I'll put that in 1C, and the CIDR block is 192.168.40.0/24. So I've got 2 of them. So as per my picture, 30.0 and 40.0, I'm just implementing what we were drawing earlier. I've got 2 subnets. Please feel free to interrupt me, or if I'm going fast, or if you're not able to catch up, please stop me, be my speed breaker. Unmute yourself or put your question in the chat. Always be happy to take a step back and explain it again. The third step here was to create a internet gateway. So I'll go back here and say internet gateways and create an internet gateway, call it IGW underscore office. Doesn't matter what the name is, but it's important to follow the naming standards of your company. Once it is created, you got to attach it because it will be detached by default. So you have to right click and just say attach to my VPC. The list of VPCs. So the VPCs that do not have a gateway attached will be listed here. You do not see all the VPCs. Just the VPCs that do not have a gateway attached will be listed. So you select that and say attach. Well, before you do that, just expand this, and you will see a command line reference and how you can do the exact same thing using CLI. And there are different things here, like how do you do it with Windows prompt, how do you do it with PowerShell, right? That makes our life much easier, right? And just say attach. So now I've got my internet gateway created. So I'll go back and mark one more item in my checklist. Next is to edit a route. I did not say create a route. I said edit a route. That means that a route will be created by default. So my route table is right here. Click on it. So out of these 3, which ones are mine? I need to expand this, and I'll see the name of my VPC, which is VPC underscore west underscore 1. I've got a question there on the chat. We can attach one internet gateway to multiple subnets. Now, you cannot attach internet gateway to subnets. What you can do is attach internet gateway to VPCs. Next, you cannot attach internet gateway to multiple VPCs. One internet gateway, one VPC. That's how the mapping is. Great. So I'll go back here. Remember not to create a route table. Always edit the existing route table, because when you create an internet gateway, a route will be created for you by default. And if you click on routes and then make enough space for yourself by moving it all the way up to the top, you will see that there is one route by default, and that says that everything is internally routable. That means all the devices inside the VPC can talk to each other, right? And if you would like to have external traffic getting into your VPC, you need to edit the route, add a route, and then put the IP address from where you want the traffic to get in. And if you want everybody to see it, then I'll say 0000/0. It is 0.0.0.0/0 means internet. It means anybody can talk to your devices in your VPC, and it will then talk to your internet gateway, which is this. So from this drop-down menu, I selected internet gateway, and my internet gateway automatically populated, and say save route. With that, we have finished the configuration of our VPC. Now our VPC is ready, and we can host the resources in the subnets in our VPC. So we created the VPC.
So what is propagated option? Propagate, yes or no?
Where is it? Edit routes. Here, right here. Is it okay? Is it coming from the top? Propagated is more related to inheritance. Is it coming from somewhere else? So you can have the route propagation written here. If you have gateways, or let's say if you have another network, a VPC to VPC communication being done, like a VPC peering, or if you want to have on-prem to VPC connection, then the routes written here will be propagated to the routes in the gateway. The propagation is more about if the routes are written somewhere else, they will be hitting your routes in the internet gateway. Yeah. Is it clear?
Okay.
Okay. So since we have created our VPC, our first VPC, let's go ahead and create few virtual machines inside it. So you go to services, go to EC2. I'm sure everybody has created an EC2 instance, right? EC2 instance.
Yes.
Yeah, because I'm just looking at my notes from the introduction. As far as I know, I think everybody has been through essentials. Yeah. Or I think a few of them who did not have training on AWS. Okay. Okay, so I'll quickly launch the instance here. Click on launch instance. Instances are nothing but virtual machines.
Anand, do we need a route for incoming traffic as well?
Good question. The route that we created for the VPC is for the incoming traffic. So we said that the traffic that is getting in and comes to the internet gateway can be from anywhere. But if I don't want this to happen and I want specific IP addresses, I will put my IP address. Now I'll just find out what is my IP address. Yeah. My IP address is this 106.212.251.222. If I go ahead and paste it here, /32, if I do that, then only I will be able to access the resources in my VPC. Nobody else can. The reason,
but I'm confused. I'm confused with the destination label. It's written over there. So if you are mentioning anything in destination column, so that's main outgoing traffic, or is it incoming? Then if incoming would be anything, then it should be in source column. But I don't see any source column over here.
You are right. There are dictionary terms. If you just look at these terms dictionary wise, destination means the traffic where it is going. Source means the traffic from where it is going. I agree with that. Now here we should not be taking at the literal meaning of this. It is if the traffic goes out from the network gateway or the internet gateway, where is it allowed to send and who can talk to the gateway? It means both basically. So if the virtual machine needs to talk to the internet, it has to go through the gateway. And if the gateway has to then send the traffic, where can it send to? Number one. Second, Who can then send the traffic to the internet gateway? Both are defined in the same column here. So if I say 0000/0, it means that the devices that are there in the subnet in the VPC will have internet. And if I do not put 00, I put my own IP address, the devices will not have internet because they will come and hit my router, and my router will not give them internet. So it's bi-directional.
Okay. Okay. Thank you.
Thank you. Okay, so I changed it back, going back to this thing. In order to create an EC2 instance, I'll click on services, click on EC2, and you'll land up in a page that looks like this, and then click on launch instance. When you click on launch instance, you get a whole menu of images. These are Amazon images, and they're published by Amazon. Some of them are published by Amazon. Some of them are published by third parties as well. For example, Microsoft, and they update it every 3 weeks so that they are patched and updated in the backend. I'll go ahead and create an Amazon Linux image, say select, and probably select a T2 micro. The T2 micro is free tier eligible. Rest of them are not. So only one that you get for free is free tier eligible. Rest of them are chargeable. How much? What is the cost per hour? Or if you really want to find that out, then you may want to go to S3 calculator, or just say AWS calculator in Google, and you'll land up in a website like this where you can punch in the numbers and find the total cost of ownership. So if you want to build a server in Virginia, let's say, okay, I want to build a server in Virginia. I want to keep it up and running at all times, 100% utilized, and the machine that I want to create is T3 2x large probably, but then you still have the options to pick and choose the instance type. Let's say in production we had like M3 instances. I'm just looking for them. Yeah, M5. Yeah, let's just go for M.
Sorry to interrupt you. Is there any like we can say nomenclature, how we can identify like what is the RAM size and the disk size or something like that? So that we can pick the sizes of the instances.
Right. Yeah. T2 micro means 1 CPU and 1 gig of RAM. So scroll down. R5D large means 2 CPUs and 16 gigs of RAM. This is the nomenclature, and R5D.large means 2 CPUs and 16 gigs of memory, if this is what you're asking for.
We can remember easily. This is very difficult to remember, like what the size of that instance is going to be. So that's what I want asking for. Like, is there any easy way to remember these instances?
We don't have to remember. We don't have to memorize what M5 4x large stands for. We never have to memorize what C5 large stands for. We, in fact, in any cloud, we would never like to memorize these numbers because these numbers change. Today, the maximum amount of storage in free tier that Amazon is allowing is 5 GB for a free tier. Tomorrow it may change because the storage is changing, the cost of storage is changing, hardware is changing. Even this cost, if I put something M5 large here, save and close, it is giving me $70. So my monthly cost is $70 for spinning up a VM of M5 large. Would it be same tomorrow? I cannot guarantee, because Amazon will cut down on this cost based on the hardware. Now, please never think of memorizing T2 micro equals 1 CPU and 1 gig of memory. Nobody will ask us, even in the exam or internally or externally in an interview. This is not
Go ahead. Why I'm asking, like, if we having an instance and that is the minimum requirement of, let's assume, for the 64 gig of memory and 2 terabyte of the disk capacity, and our vCPUs, let's assume 8 core CPUs, it is the minimum requirement for instance to run with the applications. So that's what I'm asking, if it is changing or something like that. So how we are going to manage that?
This mapping is not changing. This I'm
Okay.
just giving a general reference that these numbers change, and some of the numbers don't change like these. This mapping is not changing. T through medium will remain as 2 CPUs and 4 gigs of memory. This mapping does not change.
Thank you.
At least it hasn't changed in the limited small lifespan that I worked with Amazon Web Services. I have not seen these numbers changing, but yeah, cost has fallen down considerably in last 5 years. And other things like IOPS also we don't have to remember. Yeah. Okay, so I will choose a T2 micro instance, which is giving me 1 CPU and 1 gig of memory. But there is another lab for storage gateways. When we'll be doing a full end-to-end lab of storage gateways, we will be creating an instance of M4 X large. This is what we'll need. This is a minimum requirement for creating a storage gateway, and we'll do that later on. But now, since we just want to play around this EC2 instance, let's select T2 micro and click next. Now, how many instances do you want to create? Do you want to create spot instances? Well, it will be not difficult, neither time consuming, but I'll say this will not be the platform to go ahead and explain each one of them. I suggest that you go ahead and then look at the Amazon documentation as well, because like I said, time is critical for us, and we got to cover things related with advanced architecting. And I find that these are pretty basic things which can be addressed by the documentation as well. There are more things that I want to share. There's just a lot of things in my head that I would like to share, what my experiences are that the documentation doesn't speak. So I will leave these checkboxes and few of these drop-down menus for your practical labs later on, or look at the documentation. Networks, I'll go ahead and select my network quickly. Make sure that you have auto-assign public IP as enabled, otherwise you'll not be able to RDP or PuTTY to the instance. I've selected Linux, but just in case if you have selected Windows, you'll not be able to RDP. And if you selected Linux, you cannot PuTTY to it if you do not have a public IP. I'll say storage, let's leave it as 8 GB. That's fair enough for our lab here. But there is another lab for the storage gateways. We'll be adding multiple volumes for the same instance. It's also important to know the differences between general purpose, provision IOPS, and magnetic. Well, magnetic does not give me IOPS. It is used for very high-level sandbox testing environments, not for low-level. It doesn't guarantee any IOPS. It doesn't guarantee any throughput. But if you select general purpose, it says that I'm going to give you up to 3,000 input output per second. So this is pretty good also for development environments, not for production. But if you got mission critical loads, sensitive loads and sensitive information, thousands of transactions happening within a split second, for example, e-commerce web applications, SAP applications, ERP applications, data driven by governments, stock markets, then I would like to go for provisioned IOPS, where it will give me, well, up to 10,000 IOPS. Try putting your mouse right on top of this eye icon, and it will tell you that the maximum IOPS that it can give you is up to 16,000 IOPS. I just said 10,000 IOPS a second ago. I apologize, because a few months ago it was 10,000 and I'm still stuck to it. I think this brings to another interesting point where we should not be remembering numbers. And I'm getting into a soup by remembering the number called 10,000 IOPS. And now this number is 16,000 IOPS. The IOPS is something that not keeps on changing that frequently, but then the hardware costs considerably drop down every 6 months. Just like mobile phones. When it is released, you got a price, and after 3 months, it's priced by 2. and after another 6 months or 8 months, it is priced by 4. So it's it's just an analogy, but remembering these numbers is of no use. I remember it because a few months ago it was 10,000 IOPS, so now it is 16,000. So provision IOPS can give you an IOPS up to 16,000. So you can put 16,000 there, and what you're getting is a very high speed hard disk, which can a high speed SSD hard disk, which can handle mission critical workloads. We'll go back and stick to 400 here because I'm not running anything critical, or rather go back to the general purpose. There are a few of the things that I'll be skipping here, and I'm telling you the reason why I'm skipping is because there are a lot of things that I have to discuss, and the ones that I'm skipping are very basic and that can be figured out in the documentation too. It's more about sharing the experience than just reading docs.amazon.com. The next section is tags, and in fact these things are self-explanatory as well. For example, delete or termination checkbox and encrypted yes or no. It's pretty English there. So tags, and I'll have a couple of tags here. The maximum tags that can be assigned is 50 tags. I'm calling it as web server. You may have some more tags there. Call it as owner, who is appteam@company.com. So the reason why I use tags like a few years ago is to pull up a report. So after 6 months, I'll say how many of these devices are owned by appteam@company.com. So I get 5 out of 20. So I can charge or bill back these 5 machines to appteam@company.com and give them an invoice and say, hey, you were running a machine for 6 months and here's the bill. And you can have as many tags inside it. Say apps that are running are Apache. There's a Samba running on it. There's also probably LDAP server running on the same machine, which is highly unlikely, but I'm just putting all of them there. Next, security group is nothing but a firewall where you write the rules or put the ACLs inside the security group for the firewall. You can create a new security group or select an existing security group. It's a Linux machine and it was intelligent to pick up 22 port, right? If it's a Windows, then we'll give you 3389, which is our DP port. You may want to add more rules there. You can add as many rules as possible, right? You can add more rules one after another. And in the next section, when we do storage gateway, which is the last part of today's session, we'll be adding at least 5 or 6 rules there to allow incoming HTTP connection, NFS connection, and SMB ports for the data transaction to happen. But for now, just leave it at 22, review and launch, right? And then you just get a review section there. At no point, it asks for a user ID and password. So what user ID and password will you use? Amazon works a little bit differently. Unlike Azure, it does not give you to type in username, password, confirm password, password hint. There's nothing like that here because it uses certificates, a combination of a private key and a public key, which is called as a key pair, to log into your instance. When you click on launch, you get a pop-up. Please spend a moment to read this. You need a key pair, a public key pair that AWS will host, and a private key that you will have. Under no circumstances, you will handle the private key to anybody. You will log in and create user IDs and their respective passwords or credentials for the users of that instance, but you do not hand over the private keys to anybody. You will be custodian and guardian of the private key file, keep it in a safe place, and also make sure that your disaster recovery model is safeguarding this private key. You may want to create a new key pair. I already have a key pair called as FS, but because it's a demonstration, I will use a new key pair and call it just anything. But just like virtual machines and VPCs, key pairs also have naming standards. To follow the naming standards in your real-time production environments. Today is 4th Feb. Use that thing. and download the key pair and save it safely in your machine. The extension of this file is .pem, launch instances. Now this takes about 4 to 7 minutes to create a virtual machine, and it should be ready anytime, between 4 to 7 minutes. So while that is spinning up, I'll just make space for myself to look at the metadata. If you look at this machine has the metadata, which is instance state pending. I created a T2 micro instance. Here are my inbound rules. If I just click on it, you will see the ports that it's listening on, the image that was used, the public IP and the private IP of this instance, the VPC in which it is provisioned, subnet in which it exists, etc., and then similar properties of that virtual machine. You can pull up these properties by using API calls as well, using AWS CLI or AWS PowerShell, and that's when access keys and secret access keys will then be used. Any questions, please? So if there are no questions, I sometimes think that the whole audience has clear idea about what I was explaining about, or probably I have confused you to a level where you don't know what to ask. So if the second one is true, then please let me know, so that way I can customize and modify, maybe change things that will make it better for the training. Okay, Rakesh, thank you very much. The reason why I was saying is that when I was taking the introduction, few of us did say that they had no training on AWS. They were from only AWS background. The only reason why I was telling about this is because when we start building complex architectures, we don't want to leave out the basics and make it difficult for the people who did not have training on AWS. Okay, so I've got an instance up and running. I'll quickly launch PuttyGen. The PuttyGen is a tool that will help me convert that file called PEM file to PPK file. So what I have downloaded is a PEM file, and I need to convert that to a PPK file using PuttyGen. And then using Putty, I will log in to the EC2 instance. All right, let's go back to the PuttyGen right away. Show where is a tool there, right here, and I will load my file, which is called as I don't know what is it called as. What did I name it as? Oh, feb something, right? Feb. No, 4 feb or 04. Yeah, 04 feb.pem. There you go. And then I will save this key. So only two buttons which we care about are these two: load and save private key. Do not touch any of those radio buttons or anything of that sort. So, and save it somewhere, anywhere where you like, and say 4 feb or something. And I've got the file now. I don't need the PuttyGen anymore. And I launch Putty and copy and paste the public IP right from here and paste it there. And SSH to that virtual machine. So what I'm doing is I just copy and pasted that public IP, clicked on connection, SSH, and then clicked on auth, and browse to my file which we just created. Say open, and say open, and it will quickly launch it. The default username is ec2-user. All right, and there you go, it's logged in, right? All your Linux commands are now ready to be explored and you can work on it. Let's quickly make it a web server. Let's just quickly make it a web server basically to see if we can open certain rules there. So I'll say sudo pm install httpd, and it installs all of that stuff. Good. Then I'll also start the service, sudo service httpd start. Let's start it. Sure. Okay. Okay. So that started sudo service httpd start. It's cool. So now I've got a web server up and running, and if I just pick up this and paste it there, I must be able to browse to the website. Now, because most of us have been through the training on essentials, can someone tell me why it is not working? I just made it as a web server, but I'm not able to access it from my laptop or from my mobile phone.
Port is not allowed, not open.
Port is not open. Very good. So let's go ahead and allow the ports. I'll go to EC2 management console, and if I see the view inbound rules, I see 22 only. So I'll click on launch wizard 9, which is my security group, make space for myself, click on inbound, and because I've got 22 open, I was able to SSH clearly, but I need to allow HTTP as well. So select HTTP from this drop down menu and save it and allow it from this particular block. Is IPv4 or IPv6. So just put it there, yeah. Or you can say anywhere from this drop down menu. And if I put my IP, I'll be allowed only from my machine, and you will not be able to access it there. So if I put anywhere, you will be able to access as well, right? Now I'll refresh this page to see what happens. There you go. So you got a quick test page built up, right? This works. I'll not take much of your time, but I'll take just another minute to make it a full-blown web page, maybe custom web page. So I'll just go to sudo /var/www/html and probably just create a file right there, HTML, and I'll VI to it. I'll create a file, call it as, hey, this is my first web page in AWS. Yeah, I am excited, and save it. I just save this file. And then I refresh it. So if you see the time to market, your application is considerably down. The capital expenditure that we used to spend like years ago, we're not doing that anymore. Infrastructure is so easy to make in cloud, and your web applications can be published so quickly there. There's a lot more in VPC, and we will be diving a lot into VPC, doing VPNs, using NAT gateways, protecting from DDoS. Multiple layers of defense is something that we should be talking about. Stateless firewalls and stateful firewalls in VPCs is something that needs to be discussed. But before that, we've just set the stage, build the infrastructure to talk about those advanced things. Before I go ahead and talk about disaster recovery, right? The next topic which I'm referring to is disaster recovery. So I'll go back to my first board, right? This is what we're going to talk about. We spoke about VPCs, and there's more to it. We spoke about EC2 instances. There's a lot more to it as well. For example, snapshots, images, difference between image and a snapshot, which we will be talking about. Also monitoring using CloudWatch. And all of these dots will be joined pretty soon. So if you have any ambiguities or any clarifications that you would like to seek, please feel free to put that in the chat. If you would like to add certain points, probably I'm missing them because probably you're doing more research than me, and please feel free to put that as well in the chat for the advantage of our fellow colleagues. The next section that we are moving forward is using AWS for disaster recovery. In fact, I will use a new board here. I'll open up a new notepad using AWS for disaster recovery. Oh, the same thing that we did with Linux, you want to do with Windows, Amod?
If we can do that, will be a good, because most of the people they are from the Windows side.
Okay.
Thank you.
Let's do this. I will go ahead and create a virtual machine quickly, Amod. Yeah, in the Windows operating system. And I'll be pretty quick in doing that because we already been through this whole step. It's just the image that is changing. So I'll select Windows Server 2019 base, yeah? And because there is free tier eligible, I'm not afraid of selecting that because I probably will not be charged for it. Anything else that's not in free tier I'll be charged for that. I'll just select, and I'm happy with 1 CPU and 1 GB memory because I'm not looking at any performance thing there. I'll just make sure that the public IP is enabled, and VPC, put that in my VPC. Storage, it gives me 30 GB, fair enough. Tags, and I'll give it a name as Amod underscore requested. Amod request. And next, security group. Look at this, you'll see 3389 there, yeah? Port number 3389. Okay, review.
Yes, that is the RDP port. Thank you.
Great, awesome. So, and yeah, 4 or 5, I'll select the same key pair. So I can use one key pair for multiple instances, launch instances. That's it, same thing. Now, after a while, I will get the public IP. All I gotta do is copy this and use mstsc, paste it and hit enter. But how do you get the password for this? This is a little bit different, and it will not connect right away because this machine is still being provisioned. But if you need the password for this Windows VM, all you gotta do is right click on this and then get Windows password. I will wait for this. Let this complete, and then I'll show you how to get that. Oh, there you go, it's enabled now. Right click, get Windows password. Password is not available. Wait at least 4 minutes after launching an instance, yeah? So it's not that quick. Linux is much faster, as always. As always.
Yeah, I know. Thank you.
Yeah, I've been a fan of Windows machines for quite some time, for a very long time. But since the time I started my first step and started crawling in cloud platforms, and then I had to put my feet in Linux, and then I thought, where am I? In which world I was living from past 10 years? Why was I doing even Windows? Because I started falling in love with Linux. It's so fast, so quick. And then there's no drama about the graphics at all. So yeah, Linux is fun. But Windows made me.
So is there any, performance evaluation, like which platform is better for Windows, Azure, or AWS, or Google, and for Linux, which one is better? So is there any testing done on those?
People have tested it. Yes, people have done that testing, and in fact, this question has been asked by several of my customers as well. Say, hey, are you selling me cloud or are you selling me AWS? Which one is it? Are you selling me Azure? So as a consultant, cloud consultant, we need to be neutral about AWS and give them numbers as to how AWS can give you a better performance or Azure, or how Google Cloud can give better performance over Microsoft Azure, etc., and vice versa, right? So people have, in fact, our team, there was different teams sitting in different corner in a different world, different part of the world. They came up with several challenges and they ran stress tests. So they hosted a web application, web app. We are deviating actually. Now, if anybody is confused, I just want to tell that we were supposed to talk about this topic, which is using AWS for disaster recovery. And then a question came up which said, hey, can you show it on Windows? So I just quickly made a machine on Windows as well. Now I'm addressing the next question, which is which one is good? Which one is winning the race? AWS, Azure, or Google Cloud, right? So that's what we are answering at this time. So we hosted a web application, and this web application was dynamic in nature, dynamic website. And this was hosted on EC2 instance. Let me be more specific. This was hosted on EC2 instance. The dynamic content, which is the JPEG files. We also made some animations there, which were in the form of SWF. And then certain movies as well, which were compressed MP4 files in S3 bucket. Okay. We connected the web application so that our customers can log in to the website. And for this, we needed a database. We used DynamoDB for NoSQL purposes, the things that don't change. For example, user ID and hashes of the passwords were kept in the DynamoDB. And then we had RDS, which had pretty sensitive information, which we call it as PII, personally identifiable information. Right? We kept that in the RDS. For caching purposes, we use two things. Number one, CloudFront. Second, Elasticache. CloudFront was caching the web content, and Elasticache was caching the database. So this was used to speed up the web app or speed up the performance or reduce the latency for the users. And this setup was done in AWS, Azure, and GCP. In this list of items that I mentioned about, all of these are AWS specific terminologies. For example, DynamoDB is AWS specific. In Azure, we used DocumentDB, tables. We did not use CloudFront, but we used CDN. Elasticache, we used Redis cache in Azure. And GCP also has different terminology. We did that. And then we used certain tools to run the stress test. Stress test / availability test. Please take a look at one of the testing that Netflix does on AWS or their infrastructure on AWS. Not on the whole AWS, but their specific infrastructure on AWS. And that testing is called as monkey test. So if you Google for monkey test / disaster recovery, it's a Google or Bing or DuckDuckGo or whatever, anything. If you just Google for this, search for this string, monkey test disaster recovery, you'll land up into documentation that Netflix did on their infrastructure in AWS. So we formulated a similar strategy that Netflix does, because that is Netflix has created a benchmark on disaster recovery. a standard on disaster recovery, which most of the organizations follow. I was in Disney in Burbank in California, and they are doing the same thing. Netflix disaster recovery. In fact, the technical evangelist of Netflix walked into the Disney office, the Disney data centers, and gave them a real demo as to how they do it. We followed the same methodology that Netflix did. We used tools to stress test and availability test that will simulate a load of 200,000 hits per second and looked at metrics, looked at latency. Can the infrastructure in AWS, Azure, and Google automatically scale? And if yes, in fact, yes, they will automatically scale. But how quickly can they get back to business? We also did the monkey test where we initiated shutdown of our virtual machines, initiated deletion of virtual machines, initiated deletion of data from database and from S3 bucket, and noticed how quickly can our systems recover. Do we have enough backup mechanisms in place? Are we using Glacier properly? Are we using S3 buckets? Do you have geo replication in place? And if they are noticing, if they are being recovered in about, let's say, 6.5 seconds or probably a minute, then after recovering, are they giving me the same throughput or the same latency that it actually used to give me with production environments? Is the new environment automatically scalable? So the answer to your question cannot be a Boolean value, which is a true or false, where I do not have the right numbers, and nobody has the right numbers, in fact, to say that AWS is the best in terms of performance, or Azure has the best in terms of performance, or Google has the best in performance. Everybody has their own niche areas. Google is best, what they call it as per the performance results from third parties, not from us. Google is best in terms of storage. They got pretty quick recovery time objectives. If you have heard of this term, RTO, we were supposed to talk about it in disaster recovery. They're pretty quick in recovery time objectives and recovery point objectives. There's a lot more of discussion that we will have to go through when we specifically talk about one of the pillars called as availability or resilience, which is one of the pillars in the well-architected framework. I just wanted to give you a taste of this discussion before I just say that, hey, we were supposed to talk about it anyways in the next set of classes. But at the same time, I never wanted to say no to the question that you asked, just so to give you a taste of it. So that will leave a food for thought and leave a room for you to search and think on your own before we talk about it in the upcoming sessions. I hope this is clear. I don't remember the name of the person who asked this question, but I hope I have been able to address some part of it.
Yeah, thank you.
Thank you. All right, so it looks like our Windows machine is up and running. Just say get Windows password, browse to your file, and that's somewhere sitting in my downloads, and it says 04 febpem and decrypt password, and that is your Windows password, and you will be using that to log into your instance. Okay, Amod?
Thank you, Anand.
Awesome. Since I don't need this machine, I will quickly terminate as part of my cleanup activity, but I will leave the Linux machine on. Guys, at any point in time, like I said, I don't know which time zone you're in, and probably each of us are in different time zones. If it's time for your dinner, lunch, or I don't know if it's sunrise somewhere, probably breakfast, please do let me know. And we'll take a longer break at that time. Okay.
So will this end by 10:30 IST or you'll be extending it?
What was the schedule time? I was told it is 10:30. Is it 10:30? Are you okay with 10:30, guys?
Yes, it's at 10:30 IST.
10:30 is good? Okay. 10:30 is good. Okay. Fair enough.
So Anand, every EC2 instance will have two network interface cards. One is for public IP and one is for local IP. If EC2 instance is in a VPC.
So yes. What you see is a single network card. So I'll just go ahead and show it in the networking section, and then when you click on attach network interface, no available network interface. Okay, I do not have a network interface, but this guy. Elastic IP network interfaces. Okay, so there's one network card, and this network card has a MAC address, and it has a private IP address and a public IP address. So it is just one network card and not two network cards. So every instance will have a minimum of one network card, and that network card will have a private IP for sure. Public IP, it depends how you have configured it.
Okay. So can we reach this EC2 instance from internet via its private IP? Is it possible?
If you do,
or not?
If you do a VPN, you can.
Okay.
If you do not do a VPN, you cannot. It's just like a virtual machine that is sitting in your office. VPC is no different from that. It is a virtual private cloud. It is a private data center. Nobody can access it using a private IP, just like the virtual machine that is sitting in your office. Nobody can access it using private IP unless you are in a VPN.
Okay, got it.
Okay, great. So the next discussion is using AWS for disaster recovery, but we got a request in the chat to take a break for a while. So just like we did a few minutes ago, maybe last hour, we took a 10-minute break. It's about 9:15 here. Let's regroup at 9:25. Thank you. Thank you.
Before we leave, can you show me again where you enabled the HTTP access? For some reason, I'm having trouble finding that.
Sure. So I went to the virtual machine and then clicked on my web server. I identified my security groups, clicked on view inbound rules, and I noticed that just port 22 was open, 80 was not there. So I clicked on the next hyperlink, which shows the name, something like this. For me, it is Launch Wizard 9. For you, it may be different. But just click on it, and it will take you to a security group section. Then you click on it, click on inbound, and then edit it to add the HTTP rule from the drop-down menu and save it.
Okay, thank you.
Thank you. Welcome. Thank you very much for your patience, team. Let's get started. And we were talking about this particular topic, which is using AWS for disaster recovery. Hopefully you can see my screen. We got another 45 minutes, and hopefully we'll be able to cover quite a lot of things in this short time we got. But I won't rush. If there's something that's left, we can definitely cover tomorrow. This is an important point, and there's a white paper as well on the disaster recovery of AWS. And it's important to know the disaster recovery part of it. We would need to know the difference between traditional and disaster recovery practice in the cloud. The two important terms like recovery time objective and recovery point objective that we need to understand. Also, what are the different DR methodologies that we have as on today? It's all about preparing and recovering from a disaster just in case things go wrong. There could be equipment failures, there could be cyber attacks, terrorist attacks, natural disaster, and any one of these events can bring down your entire infrastructure. So you need to have a disaster recovery plan slated down so that you can oppose a significant downtime and financial loss in the event of a disaster. A disaster recovery plan is aimed to minimize the impact of a disaster. By training employees and documenting the disaster recovery process so it can be executed quickly, efficiently, and safely. For example, you have a disaster recovery plan to which if a disaster triggers, you will just go ahead and recover or reinstate your mission critical applications, including your email services and production application services, and thereafter you will recover your less critical applications, including the environment that you have. Note that I do not see the traditional disaster recovery wherever you go with the traditional approach, meaning that you have your entire data center set up and companies just need to duplicate their environment to another data center in a location that is remote at a primary site. So in a different location, you will have to create a duplicate infrastructure that the entire hardware and software systems or data center infrastructure has to be installed and maintained. So it is ready whenever it is required. The disaster recovery site is, in that case, is often underutilized or over proficient and is nothing but a wastage of money. That being on the hardware or the software, the applications running in your disaster recovery site would not be used in case there is no disaster. So your investment on your disaster recovery is sitting idle in case of a traditional disaster recovery and business continuity plan. Now that if you go with a cloud disaster recovery strategy, specifically Amazon, the disaster recovery site can be recovered in minutes all over the world, and then you pay it only when you are using it. You have not done any upfront investment on the hardware, the data center, or any of those things. Amazon Web Services can duplicate your infrastructure in minutes, so you do not have to set up your own data center. You don't have to buy any hardware. You can just make use of the existing regions that are available. There are zones which will help you set up a disaster recovery site. And I hope you see the difference between a traditional approach and a cloud disaster recovery technique. So if you go with the traditional approach, you as the owner of the data center, you have to take care of the facilities. You are responsible for the security and physical protection of the assets. You are also responsible for capacity planning of your infrastructure if you do it in traditional world. ISP or communicating with your ISP is your responsibility in the traditional world. Network infrastructure and its utilization, such as firewalls, routers, switches, load balancers, all of that is your responsibility in case you opt for a traditional methodology of doing a disaster recovery. You also need to do capacity planning for mission critical applications. Basically, you're responsible for everything if you're going for a traditional setup. By going to the cloud, you do not have to manage any of the ones that I just listed, but it's all going to be taken care by Amazon Web Services. So it brings down your time, effort, and cost involved in setting up your disaster recovery site. Now, there are two important considerations. With disaster recovery, data recovery, there's a RTO, which stands for recovery time objective, stands for RTO. And the other one is RPO, which is recovery point objective. When we talk about disaster recovery, these are the two terms that we must know, we must be aware of. So what is disaster, or what is recovery time objective, or what is recovery point objective? With recovery time, it is corrective. It is a time when it takes after disrupting to restore business processes to an acceptable service level. So if we just make a note of it, recovery time objective is time it takes after a disruption. To restore business processes to acceptable SLA, service level agreements. For example, at 2 p.m., your data center, all the infrastructure goes down and you have to set up your recovery time objective. And let's say the recovery time objective is 8 hours. That means if the data center has gone down at 2 p.m., the data center must be up and running by 10 a.m. or 10 p.m. on the same day. So it is deemed that if the recovery time objective is 5 hours, the business will be up and running in 5 hours. It is a time frame your infrastructure should be up and running just in case a disruption happens after the disaster triggers. So after disaster triggers, you set up an automatic recovery based on the time objective, and you expect your entire infrastructure to be up and running. That's an important terminology. Then is recovery point objective, which tells me how much of a data can I recover back. So if you're losing certain data, then that is a loss for your business. Till what point I can come back the business to? Any data that has been stored needs to be backed up and needs to be reinstated. But at times not everything is backed up. So if you have backups happening every 30 minutes, or let's say 1 hour, your backups are happening every 60 minutes, and the backup is triggered at 10 a.m., 11 a.m., 12 a.m., 1 p.m., etc. The disaster happens at 11:30, right? Disaster happens at 11:30. Till what point can you restore the backup up to? It is this backup that needs to be restored or triggered. This one. That means you're still losing 30 minutes of data. The recovery point objective is not about how quickly you can restore, but it's about how much of data can the company actually bear. Are these terms clear for you? Recovery time objective and recovery point objective.
Yes.
Okay. So let's start with another discussion, which is called as backup, restore, backup restore, and there's another term called pilot light and warm standby. And the third one is multi-site disaster recovery. So these are the 4 disaster recovery methodologies. The backup restore, pilot light, warm standby, and multi-site. And backup and restore is the most basic recovery technique where your data has been backed up using a tape disk, tape disk, or has been sent to an offsite storage. And that is usually done on daily basis. In the event of a disaster, all your data that has been recovered from these backup tapes is now restored. But of course, it can take a long time because your offsite storage can be just too far away from the actual disasters or actual place where the disaster happened. In that case, the recovery time objective will be high. There is an organization called as Iron Mountain. You might have heard of it. Iron Mountain is an organization that is one of the best in class as far as backups is concerned. They don't take backups, but they store your backup tapes, and they will come to your office, pick up your tapes, put it in a vault, encrypt it, put a lock on it, give a key to you as well. They have a key themselves, and they'll take it to a different location, which they call it as volcano proof, nature proof, or whatever, tsunami proof, etc. So most of the banking companies use that. Iron Mountain is kind of an expensive service, right? So as we move from top to bottom, you will see that the recovery time increases. Here I've got the recovery time in the slowest possible way, because if the backup is an offsite storage, then it is taking a long time to restore the data. Let's now you come and get to the next point, which is pilot light. What is pilot light now? Now we know that backup and disaster recovery is kind of a very old technique, and hence we move on to the next one. Probably even in backup and restore method, you use backups being sent to S3. So we can still use Amazon Web Services as a mechanism where you are sending the data to S3, and then from S3 you send it to Glacier based on the lifecycle policies. But that still takes some time. The pilot light allows you to run a minimal version of your environment in the cloud. In case of a DR, or in case of a disaster, well, not a DR, but in case of a disaster, you can scale up to the standby version. So in pilot light, the RTO is medium, because you have a minimal version, and the RPO is sometimes low to medium depending on the frequency of replication. So if your prod and the instances in your minimal version in a different environment are being replicating very quickly, very fast, then RPO will be low. And if they are replicating very slowly and the delay or the schedule is at varied intervals, then RPO will be medium. That is nothing but a pilot light environment. In AWS pilot light, let's talk specifically about AWS now. In AWS, you got services like AWS RDS or EC2. right? So for this, you will build, what's that, 2? For this, you will build replicas of your primary instances. It could be RDS or EC2, but regardless of what it is, you'll build primary instances of the database, or primary instances, copies of replicas of your primary instances, and then replicate data to them via, let's say if it is a database, then you will use AWS database migration services. Pardon my spelling mistake there. And if it's an EC2 instance, you will take snapshots on AWS S3 buckets. You can also use Amazon machine images, which are ready to deploy. So just in case things go wrong, you have the machine images. All you got to do is right click and launch an instance from the AMI. AMI stands for Amazon Machine Images. So you'll have images ready. They are ready to deploy. The AMIs of your business infrastructure. That can be quickly be provisioned and brought online. And the third thing that you can use is elastic load balancers. So they are used to point traffic to the newly created AWS resources. Via, you can use either ELB or maybe use DNS round robin. So when I said new instances can be created using the replica option or images, the traffic can be directed to them using ELBs, elastic load balancers, right? So let's go ahead and draw a picture of this AWS Pilot Lite environment. On your left side, I will have kind of an infrastructure right there, and draw this pretty quickly. And here I have maybe a caching server or a reverse proxy. So the traffic gets in, and the name of the website is let's say www.myproducts.com. It's an e-commerce site. The traffic gets in from the internet, gets into the caching server, which is a content delivery network or a caching server, and from there it goes to your actual EC2 instance, which is that. So I'll put that as an app server, and then it then connects to a database, which is the master database. So I'll name it as master database. All right, cool. Now in a light sail environment, now this could be in your production environment, or it could be production on-premise environment, or in cloud, or probably in a different cloud. Doesn't matter. We're talking about disaster recovery. So in a light sail, in a Pilot Lite AWS disaster recovery environment, you will create a separate environment in AWS. Now this is your AWS infra, and you will have a similar kind of a setup here. You will have a similar setup: a reverse proxy / caching server, and you'll also have an application server, and then you'll also have a database server. What you will also have is a constant replication happening between the two databases. There's a constant replication happening between the master database and the database server in the AWS infrastructure. And none of this infrastructure is actually running. You will create it and then shut them down. When you have database servers, at the time of synchronizing, just a few minutes before, you will just power it on. Synchronization happens and you shut it down, right? So by doing so, you are actually not paying for any of the items. You're just creating the resources, and you may be paying very less, a meager amount of money for provisioning the resources, because keep in mind that when you create virtual machines, you will pay for the hard disk, the SSD that you have provisioned, and that is very minimal, very minimal. So on the left side is your production environment. On the right side, you have the minimal version of infrastructure which is running, but these servers are not running. They're not up and running. Probably you can think about having just the database server on to reduce the recovery point objective. So the data is being mirrored to the secondary infrastructure in AWS, which is probably stopped, or some of the infrastructure is up and running. There could be data synchronization between application servers as well. Depends on what it is. So if your actual data center goes down, what happens is you trigger a power on AWS infra, and then the servers will get up and running, and the traffic then gets into the pilot light version of your data center. So you can then route your domains traffic using Route 53 as well, which is the DNS aspect of AWS. Is this clear? So I'll just put.
Will we have the practical for this, the pilot, like this model of disaster recovery? Will we have the lab for this?
We cannot do an end-to-end. I'm not saying it's technically not possible, but there are a few things that I can show that, for example, taking a snapshot of the database automatically, or taking a snapshot of your virtual machine automatically, and then integrating that with CloudWatch. That is part of the labs. And even Route 53, Route 53 can be shown in the lab part of it. So the traffic is first, the name is first resolved using the DNS. The traffic can be redirected using, let's say the traffic is going here 100%, because in Route 53 you can configure it in one of the methods called as, let's say, priority mode. So 100% of the traffic goes to your actual main data center, but then just in case things go wrong, a secondary setup can be done here, and it goes to the second data center. So this is in priority. 100% of the traffic goes to your main data center, but things go wrong, it is then going to your pilot light failover environment. In this case of pilot light, you need to make sure a few things. I'll just make a note of it. Where is it? Yeah. Okay. In case of pilot light, the key steps to configure this are that you need to ensure you have all the supporting software packages available in AWS. Because if you got such an infrastructure and this application is customized, that means you have a custom application up and running, and you do not have such an image in AWS, then that's a problem. You have to figure out a way as to how you can get that specific image in AWS. Then you need to create and maintain AMIs of key servers where fast recovery is required. And as a create, you know what create is, but maintaining them. Creating of images can of course be done right from the console. So if you click on it and then right click on your instance, there is a way to create an image. Click on create image, put some values there and click on this, it will create an image for you. But how do you maintain it? Maintain it means patching it, updating it. That must be done on timely intervals, installing antivirus, updating the signatures of the antivirus, patching, updating the patches, etc. That must also be done on timely basis because you cannot have older versions of operating systems with vulnerabilities provisioned in production environments. You also need to regularly run the servers, test them, and apply any software updates. And any configuration changes that needs to be done. When I say regularly run these servers, I was referring to these machines. You cannot have them off. Well, you can technically, but it's not just recommended to do that. So you will have these servers up and running for some time. Usually people do it once in a quarter, power them on, update them, patch them, see if it's actually working, and then shut them down again. Specifically in case of RDS. So when using RDS, you need to turn on multi-AZ or multi-AZ to improve resiliency or availability. Multi-AZ is a concept where you will have your data provisioned in multiple availability zones in the same region. And then we use Route 53 to point the traffic at the EC2 servers. You will have monitoring built into Route 53. So just in case things go wrong, how will Route 53 know that this environment is down? Because Route 53 will be monitoring it. So CloudWatch will then integrate to Route 53. There's an availability section in Route 53 where you define and you create a heartbeat and say that, hey, Route 53, you monitor this server and say, hey, is it listening on port number 80? And it constantly keeps on polling and sends a heartbeat signal to the production environments. And just in case it does not receive a signal back, it will wait for some time. And the some time that I said, the duration can also be specified in Route 53, and it can then be sent to the light environment that you've set up in AWS. So these are the steps that you will follow when you're provisioning your infrastructure in pilot light environment. Any questions?
So if we are storing the data from the master server to your database server in AWS, there will be a cost, right? Because of the content that we will be storing in the database.
Agreed. Yeah. 100% yes.
Even if they are not running.
If they are not running, say in AWS you pay for at least three things, right? One is CPU and memory. You pay for that. You pay for storage, either it is SSD or HDD, right? And then you pay for network IOPS. If you are transacting the traffic, data in transit, right? Network IOPS is data in transit or in motion, right? So you pay for these things, right? At least these three things minimum. So if you're shutting down the machine, right, if you have your VM on, you pay for all these three things. But if you have this whole thing in shutdown state, you don't pay for this, You don't pay for, well, you do pay for this, right? Because you have not deleted your HDD, you have not deleted the storage. Just the VM is shut down. And because it is shut down, there cannot be any network transactions, right? So what you pay for is this, which is very low. In traditional environments, you had to pay for all of this because you gotta buy them. Even if you shut them down, you have already paid for it. It is a capital expenditure. But in cloud, if you have a disaster recovery setup, it depends on how much you're using and how much of data transactions you have, network transactions, data transactions, and CPU and memory. So in this pilot light environment, you'll have a disaster recovery setup in a different environment, and after setting it up, you shut them down, so you don't pay for the CPU and memory, you don't pay for the network apps, you just pay for the storage and HDD, storage SSD or HDD, right?
And also, is it possible for this AWS infrastructure that for application server which is running in our DC to get that image created for that and have it running in AWS?
So you're asking how do you create an image and how do we do that? Is that right?
Image of, the server running in our DC, like not in AWS.
Okay. All right. So how do we move? Move the virtual machine from on-premise to the cloud? Basically, it could be a server migration. It could be total server migration, or you just create a virtual hard disk, download the VHD, upload it to the S3 bucket, and then using CLI tools, you can provision a VM from the virtual hard disk that is there in S3 bucket, and then that VM can be created in the EC2 instance. Is that
Where doc for that? Is it there?
Sure. Let me find a documentation for you on that one, how to do that step by step. Just give me another day. I think it's somewhere sitting in my repository. I'll find that and send it to you, maybe the whole team. People have done that actually. They just send it to S3 bucket. People take images on timely basis. Usually take snapshots on timely basis. Images are done just once, and then they send it to their S3 bucket for disaster recovery purposes. So there's a question in the chat to create an image of a machine in your DC. Okay, so Amit, is that what you were asking as well?
Yes.
Okay. Awesome. So yeah, that is about Pilot Light. The next one is warm standby. Now, warm standby just extends the idea of Pilot Light, right? Just say it extends. So we're talking about warm standby. So it extends the Pilot Light by running a scaled down version. You run a scaled down version of a fully functional environment always running in the cloud. So Pilot Light is created and you shut it down, but the warm standby is created with a scaled down version. Scale down, up and running. These are the points at all times in the cloud, right? So Pilot Light is shut down. You create it, you shut it down. Warm standby, you create it, but then it will be of very low little configuration. So it decreases what? The recovery time objective. Because the critical systems are always operational, they're already running. The warm standby site can either be on instances ready for production or on lower sized instances that can be scaled as required. Right. So we can draw a similar picture here. Now in this case, if I just go ahead to modify this little diagram which we created for light version of AWS disaster recovery, here I will not only have the database is replicating, but I will have the application talking to my database, application talking to this database, caching server. Yeah, it will be talking to the Route 53, and yeah, it will still be in priority mode, but it is not active. And if it cannot find the route to this network, it will then send the traffic. Is there a way I can? I'll just leave it there. So there will be more of transactions happening between, there's a constant sync that happens between production and the DR environment. So both of them are constantly active, but the one that is not serving the production environment will have very low or scaled down version of the production environment. So it is standby, but you do not have to invoke it. In light mode, you have to invoke it because all of those machines are in shutdown mode. So you route the entire traffic by using Traffic Manager or Route 53. So that is nothing but a warm standby. Then the next one is high availability in multi-AZ environments. So in high availability in multi-AZ environments, you will have the same setup, but then now it is available in multiple availability zones. Things get triggered, and it can be manual or automatic. So if I have to make notes on that, which is HA, high availability on multi-AZ environments. High availability can be manual or automatic. If it is manual, of course, it is done by humans, and automatic is either scripted or you'll use CloudWatch to trigger a DR or disaster recovery. And you have that in RDS, relational databases, and even in EC2 instances. So if we go ahead and create a RDS instance, and then you reboot the instance, you will have the options to reboot in a different AZ. Let's say you created an RDS with a multi-AZ option. Yeah, you create an RDS with multi-AZ option, and then you do a manual failover. Right? Do a manual failover. During reboot, it will ask, do you want to create it in a different AZ or same AZ? An automatic is done with CloudWatch. That means DR happens based on events that are written to CloudWatch. I just gave an example of RDS here, but it could be EC2 instance as well. EC2 instance depends on what? EC2, the heart of EC2 instance is the volumes, right? And for these volumes, you can take snapshots. Snapshots can be manual or it can be automatic. So you can write rules in CloudWatch to trigger what? Trigger snapshot of database, snapshot of volume if things go wrong, if the VM is down, if the VM is being rebooted, somebody hacked it, compromised it, anything. So if something happens, do this. Is nothing but the rules in CloudWatch. So basically, high availability on multi-AZ can be manual or automatic. Manual is something that you do. For example, if I go here, I've got volume sitting there. I can just right click and say take a snapshot, create snapshot right away. Right? This is manual part. Another one is when I go to CloudWatch. I go to CloudWatch. And under CloudWatch, you can write a rule to say when a snapshot must be taken. And in fact, it can restore as well. Let's just quickly show that to you. Go to rules, create a rule. When you click on create rule, you get two panes, one on the left side, the other on the right side. Here you define the if part. You define the if part. And on the right side, you define the do part. So if this happens, do this. For example, let's say if the EC2 instance changes its notification specific state, let's say if it is shutting down, somebody is shutting this down, yeah, then immediately maybe send an email to an SNS topic, or you take a snapshot, create a snapshot immediately, and you put the volume ID there, and you can get the volume ID from the EC2 instance. Okay. Yeah, so you just put that's the volume ID. Just copy this volume ID and paste it there. So when the VM shuts down or changes its state to shutting down, it will take a snapshot immediately, right? This is a proactive way, or you can also schedule it and say, hey, take a snapshot every couple of minutes, right, of this volume ID. Have I copied something? No. So I can just copy this, go back there. All right, done. So every 5 minutes, 5 minutes is just too much in production environments, so I'll say every 2 hours, or you can just specify a cron expression as well for a cron job. It's a fixed rate of 2 hours, take a snapshot, right? This is automatic, hands-free deployment. Clear? Any questions?